Okay, so solve the equation 3 cos theta plus cot theta is equal to 0 for theta, for values of theta between 0 and 90 degrees. This is part A, question 6 of 2024 external paper for ADMA. This was paper 2. So I thought I should make a tutorial video for you guys. Okay, so this one, to solve this equation, you know that this is cot. You know that cot theta is defined as cos theta over sine theta. So you can just substitute this in there and say this is 3 cos theta plus, instead of using cot there, you can use cos theta over sine theta and equate everything to 0. So now, even at this point, you can factor cos out, but I think it's much easier when you just find the common denominator or multiply everything by sine. So I'll find the common denominator. I think it's more relatable that way. So if we can find the common denominator, which is sine, some people put a 1 here. So you can say 1 into sine theta, this is sine theta. Then sine theta times 3 cos theta, this will be 3 cos theta sine theta. Then plus sine theta into sine theta is 1. 1 times cos theta, still cos theta. Then this is equal to 0. Yes, so when you do this, you can even see the answer. So others will put a 1 there and cross multiply. So when you say this part multiplied by 1, this will be cos theta sine theta plus cos theta, and this must be equal to 0. So now to solve this, you can factor the cos out. So once you factor the cos out, you remain with 3 sine theta here, and then you have a 1 there, which will be equal to 0. So now when you have two numbers multiplying, like A multiplied by B, and the answer is 0, then either this number or this number, or even both, is equal to 0. So when A is equal to 0, the product will be 0. When B is equal to 0, the product will be 0. When A and B are both equal to 0, then the product will still be 0. So we can use this fact here. So when you are multiplying this by this and the product is 0, it means either this or this is equal to 0, or even both. So you can say cos theta is equal to 0, or 3 sine theta plus 1 is equal to 0. So now let's start with this one. So now when you have a 0 like this, you know that 0 is neither positive nor negative. So you can't tell in which quadrant this one is found. But you know the axis you are dealing with, right? When you have this one will be your 0, this one will be your 90. These are the 4 quadrants, by the way. Then this will be 270. Then this one will be actually this is 180, sorry. Then 270, then back to 0 or 360 if you wish to call it that. Yes, so now the only time you have a 0 is when you have cos as a 90. So cos 90 is equal to 0. So your theta here will be 0. Your other, 90. Your other theta will be this one here, because you are dealing with this axis. There is no need to find quadrants here because 0 tells you that you are dealing with boundaries. Yes, because 0 is a neutral number, so this one will be 270. You can even verify the answer by using this and that. Okay, so we're done this side. Then let's look at the other side too. This side we have 3 sine theta is if you were to take the one to the other side, you have this. Divide both sides by 3. You have sine theta is equal to -1/3. So now you want your theta. But before you find your theta, you need to find your alpha. And then after finding your alpha, this is defined as sine alpha is equal to the modulus of whatever you've been given. And then since this is negative, it means your theta is in the third and fourth quadrant, because sine is negative in the third and fourth quadrant. Yeah, so now sine alpha will be 1/3. Then you can use your calculator to find it. So this is mine. So you can say sine inverse of 1 divided by 3. So make sure your calculator is in degrees. So this one is giving me alpha as 19.4712. So to improve the accuracy of your answer, you can write your alpha correct to 4 decimal places and then just round the final answer off correct to 1 decimal place, since you're dealing with degrees here. So in the third quadrant, theta is defined as alpha plus 180. So now theta here will be alpha is 19.4712 plus 180 degrees. So now let's add this one plus 180 degrees. This will give us 199.4712. So because of space, I'll just write the final answer instead of, but under normal circumstances, you should write this correct to 4 decimal places and then you can round it off correct to 1 decimal place, since you're dealing with angles in degrees. So this will be 199.5 degrees, and you are done this side. And then for the other angle, for theta in the fourth quadrant, theta there is defined by 360 minus alpha. Okay, so theta will be 360 minus our alpha, which is 19.4712. So let me punch it on my calculator. 360 minus 19.4712. So our other theta will be 340 point, I'll just write 0.5 degrees. And then it's always important to make a conclusion. So you can say, therefore, theta is equal to, you list down all these angles in their increasing order. So you can start with 90, which is our smallest angle, then move on to 199.5, and then 270 degrees. Of course, this will be 0.0. Remember, angles must all be rounded off to one decimal place. Maybe this may not be necessary. And then the last one is 340.5 degrees, and this is it for this part. And then part 2. This was an interesting question. Given that tan theta is equal to n, where theta is an acute angle, find in terms of n cos theta. So now you need to mess around with the identities you know so far. So for the first one, you can start by writing down tan theta in terms of sine and cosine. We know that tan theta is equal to sine theta over cos theta. And then you also know that tan theta here is n from this information there. So where there is tan, you can put n. Then you have sine theta over cos theta. So now you can cross multiply here and get something like this. Sine theta is equal to n cos theta. So now, since you're trying to find cos theta in terms of n, your job is to get rid of the sine. Do whatever you need to do to eliminate the sine. So for me, I know that we have this relationship, the Pythagorean equation, one of the most famous equations in mathematics or identities in mathematics. So I can make, perhaps even without changing the subject or the formula, I can just substitute this part with this. Since my job here is to eliminate the sine so that I just remain with a cosine. Remember, we are trying to find cos theta. So where there is sine squared theta, I'm going to put n cos theta. Of course, there is a square there, plus cos squared theta, and this must be equal to n. So now, there's a square there. Remember, our job here, or our mission, is to get a cos theta out of this. In short, we are just trying to make cos theta the subject of the formula. So you can say cos squared theta. I'm just factoring the cos squared theta out. This one will be n squared plus this would be a 1. Then this is equal to 1. Then we can divide both sides by n squared plus 1. So let's divide both sides by n squared plus 1, n squared plus 1. So that this one will divide with this. Then you have a 1. So you have cos squared theta is equal to 1 over n squared theta plus 1. So now, remember, we are not trying to find cos squared theta. We are trying to find cos theta. So in this case, I'll introduce the square root on both sides. I can do this. The square root of cos squared theta is cos theta. And then you have two possibilities here. You can either have a positive or a negative. But then, since you have been told in the opening statement that theta is an acute angle, you know that an acute angle is found in the first and is found in the first quadrant, because you are talking about angles between 0 and 90, perhaps not limited to, but within this range. So that means you are in the first quadrant. So in such a case, you know that cos theta is positive there. So you can say the square root of 1 is 1, and then this one will be like that. So this will be positive. If the angle was not acute, if let's say the angle was in the second quadrant, in the case of an obtuse angle, then this would have been a negative number. Okay, let's proceed to the next one. So here we have cos 2 theta. We want to find this using the only information we have in the opening statement, which is tan theta is n and theta is an acute angle. So we can expand this. So I don't want to straight away go to that identity, so I'll use the basic ones. This is the same as cos squared theta minus sine squared theta. So in case you are not sure what to do there, this identity is always provided. So now you have cos 2 theta. You're trying to find cos 2 theta here, so you may not need the sign. So what you do here is you can change it to cosine, and the easiest way is by using this identity there. You can make cos squared the subject. You can make sine squared theta the subject and substitute it in there. So what I mean is this: when we make sine squared theta here the subject, you should have 1 minus cos squared theta. Yes, so this one will be cos squared theta minus, in brackets you can put this 1 minus cos squared theta. Remember, you are just substituting this with its value, since sine squared theta is this, so this has gone there like that. Okay, so next, let's simplify it. This will be cos squared theta minus 1 plus cos squared theta. So if you're already familiar with this identity, you can straight away just use it. This plus this is 2 cos theta minus 1. So if you already know this identity, you can just quickly use it. You really don't need to go through this. So we can say cos 2 theta is equal to 2 cos squared theta minus 1. And then from here, we know that cos squared theta is 1 over n squared plus 1. Or maybe we know that cos theta is 1 over this. But I want to use this version here. Okay, so I got a little distracted. So now, where there is this, you can just put this. Remember, without the square roots there, cos squared theta is equal to 1 over n squared plus 1. So where there is this, you can just put 1 over n squared plus 1, then minus 1 like this. Okay, so now all you need to do is to simplify this. So this times this will be 2, then n squared plus 1 minus 1. And then when you find the common denominator, you have n squared plus 1. And then this into this is 1 times 2, which is 2. Then you can put the 1 there if you want. Then 1 into n squared plus this is n squared plus 1. You multiply it by negative 1. So please make sure you use the brackets here. It's very important unless you want to mess up with the signs. So you have 2. This times this will be n squared minus 1, then over n squared plus 1. So now 2 minus 1 is 1 minus n squared, and then you have n squared plus 1, and you are done. Others would rather write it like this, so that you have the n's on one side and the ones on the other side. Okay, have a wonderful day.